Hi students, today I am going to explain what are the factors affecting the radii of ions. So first we should know what is ionic radii or ionic radius. So ionic radius is the measure of the distance between the nucleus of an ion and the outermost edge of the electron cloud. So when we take an ion or atom, so ionic radius, we know the what is radius from the distance from the center to the outermost edge. Same here also, it is the distance between the nucleus, which is the centermost, and the outermost edge of the electron cloud. So ionic radius is most accurately measured by having the distance between two bonded ions. When we take two bonded ions like cation and anion, then the distance between the two bonded ions is nothing but the ionic radius. So from here to here, so and we can say R anion, radius anion plus radius cation is equal to ionic radius. So in ionic compounds, the sum of the ionic radii of cation and anion gives the distance between the ions in crystal lattice. Then what are the factors affecting the radii of ions? We can say ionic radius of cations decreases steadily along a period. When we go on in a periods, so in a periodic table, so the ionic radius of cations decreases steadily as ionic charge increases. When we see the charge is increasing, the cation size also decreases along the main group metals. In the main group metals, with the increase in the charge, the cation size decreases. So Na plus is bigger than Mg2 plus and Al3 plus is the small. So with the increase of the charge, the cation size decreases. If we take the same cation, here also ionic size decreases with the increase in oxidation state. So here also with the increase of charge or in the oxidation state, the cation size will be decreased. So same iron in 2 plus, it is little big than Fe3 plus and compared to Fe4 plus. So there will be a decrease in the cation, so ion size. Then for transition metals, if we see, the multiplicity of the spin state affects the approach of anion towards the cation. So how the anion approach towards the cation? So in transition metals, the multiplicity of the spin state. So how the spin takes place, that will affect the approach of anion towards the cation. And for both cations and anions, crystal radius increases with increasing in coordination number. If the coordination number is increasing, then there will be the increase in the crystal radius. So what is coordination number? Let's see here. Coordination number is nothing but the number of anions that can fit around a cation is called coordination number. So around a cation, so many anions will be surrounded. So that number of anions which is surrounding that cation is nothing but coordination number. If coordination number increases, then radius ratio also increases and also the crystal radius also increases. Then ionic size increases down the group for both cations and anions. So ionic size decreases along a period and increases along a down the group. Then so these are the factors affecting the radii of ions. Very easy. It decreases along a period and increases down the group. As the charge increases, their size decreases. In the same cation also, again the oxidation state increase with the charge increase, the ionic size decreases. And for both cations and anions, with increase in coordination number also, the crystal radius increases, the size increases. So these are the factors. Then what is radius ratio? Here the ratio of radius of cation by radius of anion is nothing but the radius ratio. Radius of cation R plus by R minus is radius ratio. So with the increase of coordination number, this radius ratio also increases. Then what is the importance? Why we have to calculate this radius ratio? What is importance? Let's see. The structure of ionic compounds is directly depend on the radius ratio and their relative coordination number. So These two are very important to know the structure of ionic compounds. If you want to know the ionic compound structure, we should calculate the radius ratio and also the coordination number. Then, so radius ratio plays an important role in the determining the stable structure of an ionic crystal. So, to find out whether the crystal structure is stable form or unstable or anything, so it's a structure. So, we have to calculate the radius ratio and also the coordination number. So, that's all. Thank you.